students, welcome back to our channel Diksha Karnataka. So I know all of you are very busy in your preparation for midterm examinations, and while making videos and seeing the comments, I found a lot of students requesting for making a video on how to use log table and anti-log table. So it is a very integral part of chemistry because you need to solve questions which involve log and anti-log. So in this video I'll be taking a lot of examples and explaining you how can you use log and anti-log table. Okay, so let us start with this video. So first of all, in chemistry, in which type of questions can we expect log and anti-log? Okay, so these are the questions from where, these are topics from where you can expect log and anti-log. Okay, so if you remember Nernst equation, what is Nernst equation? We have E of the cell is equal to E naught of the cell minus 0.059 by N log of product concentration by reactant concentration, okay, into the power of stoichiometric coefficients, right? Now here what happens, generally the log values, okay, log values like are in the powers of 10. So it is very easy to solve generally Nernst equation log values. Okay, we do not find like log any number, we do not get log of 10 to the power of something, generally we get. Okay, next coming to Gibbs free energy question. So Gibbs free energy, you know, delta G is equal to minus, we need when the cell is at equilibrium. Okay, what is the condition? So I am revising the formulas here also. If the cell is at equilibrium, E will be equal to 0. So I will get E naught is equal to 0.059 by N log of K, and many a times the value of K is asked to you directly. Okay, so in that time you need to know how to find anti-log also. And for example, if delta G is asked, minus 2.303 RT log of K, so here also you need to know how to find the K value. Apart from this, also in chemical kinetics first order reactions we need the formula. Okay, so chemical kinetics also includes this log question. Okay, so now finding log is very easy if we have the power of 10. Like I will be telling you some basics now. Suppose if you have, see, if you have log of 10 to the, so let me first erase this one. Yeah, so now if you have log of 10 to the power of 4, okay, or let me take it as x, okay, that is equal to x log 10, okay, and log 10 value is 1, so that is why we can say that is equal to x. Okay, so clear, log anything to the power of x is x. So I can say log of 10 to the power of 4 is 4, log of 10 to the power of 3 is 3, log of 10 to the power of minus 2 is minus 2. Okay, this is what we can easily find if log of some 10 to the power of something is given. Now how to find, suppose log of 43.4 is given. Okay, for these type of numbers we need to, or any other, if it is not a power of 10, then we need to use log table and anti-log table. Okay, so first we'll discuss how to find log table, then we'll discuss how to find anti-log table. Okay, fine. So this is how a log table looks like. Okay, here you can see this first column, okay, contains number 10, 11, 12, 13 like this. Okay, and this one, this part is called as difference table. Okay, this is difference table, and this part is called as mean difference table. Okay, so this columns will be difference table and next one is called as mean difference table. So this is how a log table looks. Okay, now we will go and solve some questions. So okay, so first I'll tell you how to find the log of a 4-digit number. Okay, so suppose we have to find log of 1732. Okay, so what you have to do, you need to, okay, now I'll show you the log table. So in the log table you need to see the first 2 digits. Okay, you have to see the first 2 digits. What is the first 2 digit here? 17. Okay, so you need to check 17 from the log table. Clear? Then what is the next digit? 3. So this next digit should be seen in the, this is what, main difference table, and this is mean difference, right? So this difference table you need to check 3. So that is 3. So 17th row, sorry, one second. Yeah, so 17th row and 3rd column, this value will be the, this value is required here. Okay, how much it is, what I am taking, first 2 digit is 17, I took from the main column, first column, Then third, this is the difference table. This one I have to take from the difference table, and this value is 2380. So let me note down this one, 2380. After that I have 2, okay, another 2 is there, and that is in the last fourth digit you need to take from the mean difference, okay. So you see 1, 2, 3, 4. So we need 2 here, right? So 2 and this value. So that is your 5, okay. So this value 5 you need to add here, okay. So what will I get? 2385, okay. That answer is not yet over. I am just telling what you need to do. First thing, 17, check 17 here. The next digit is 3. I'll check 17th row and this column. What is the value? 2380. Next, last digit is 2. That I need to take in the mean difference table. So 1, 2. But if it is 3, you need to check 3. If it is 4, you need to check 4. So because here it is 2, I am checking 2. Again, which one? The 17th row, okay. And that value is 5. So I will add this to 2385. I got 2385. Now what I need to do? Now what you have to do? See, how many digits are here? 4 digits are there. You need to subtract 1 from here. So what I'll get? 4 minus 1, that is 3. So I need to put a decimal here and write 3.2385. What is the last step? Count the total number of digits, okay. Then subtract 1 from there. So we will get 3 and then put that number with a decimal. Okay. Now I'll tell you why we are doing like this. So when you solve this, you need to write it like this. See, I'll tell you the long cut now. See, if I'm telling you the long cut, how we will get? Just a minute. See here. So 1.732. How we can write down? 1.732. Okay. Can be written, 1732 can be written like this. 1.732 into 10 to the power of 3. So now what I need to do? I'll write log of, one formula for log is there like this. See, log of A into B is equal to log A plus log B. Okay, that is required. So now here I need log 1.732 plus log of 10 to the power of 3. Okay, now log 1732, how we will find? Using the same method. Okay, how much we'll got? First we'll take 17, the 17 value, then 17th row, the third column we will get this one, 0.2385, right? Next, log of 10 to the power of x is x, so I'll get 3, so I'll get 3.2385. Okay, that is what I got a trick here, that okay, if there are 4 digits, I'll subtract 1 from that. 4 minus 1 is 3, so I'll put 3 point something. Clear? Okay, so step, again we'll revise this one. Once again I'll tell you. First what you need to do, okay, we'll erase everything and start once again. 17 is there. First 2 digit you need to consider. Check 17 where it is, 17. Then next digit is 3. So 17th column, third number is 2380. Okay, so 2380. Then fourth one is 2. So that you need to check here, 2 here. 17th column again this one, right? So that number is 5. We need to add this one, 2385. Okay, next, how many digits are here? 4. 4 minus 1 is 3. So I'll put 3.2385. Okay, so correct answer is what? 3.2385 here. Got it? Okay, next example we'll see 3 digits if it is a 3-digit number. Okay, I have taken log of 229. Okay, log of 229. So again what we will do? First we will check 22. Okay, first 2 digits you need to consider. 22. Yeah, we have 22 here. Okay, then 9th number from here. Okay, so what I got here? 3598. So there is no other digit, so we will not see this one. Mean difference will be seen if there is a 4th digit. So first 2 digit here, 3rd digit here, 4th digit here. We do not have any 4th digit, so we will stop here. 3598 I got. Okay, I got 3598. Now what you have to do? How many digits are here? 3, subtract 1 and I'll get 2. So I'll put 2.3598. Okay, that is the answer for log of 229. Clear? Next, if you see, next we'll find for 2-digit number. Okay, log 29. So if you see, this is the table. So this is the main table and then this is the difference table. Okay, and this is the, okay, I have taken only difference table. Now 29 is there. Now you need to, so this in this main difference table, see, in this difference table we have like this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if it's nothing, 29 is there, after that nothing is there, you can imagine like 290 is there. Just imagine like this. If only 29 is there, after that no digit, then you need to imagine is at 290, suppose, okay? So what we'll say, first two digits will take from here, 29, first two digits I have taken here, then this is 0, so what is this value? 4624, so I will write first 4624, okay? Now see, there are two digits here, so 2 minus 1, that is 1, so I'll get 1.4624, okay? So answer for this question will be 1.4624, okay? You can see 1.4624. Okay, now let us do for single digit, okay? Suppose you want to just find log 9. So in this, this table starts from 10, okay? 10 to 99 it is there. So 9 is there means nothing is there, I will imagine it as 90, okay? So 90, okay? Then after that also nothing is there, so again 10 I will imagine, so I'll take this one, right? So we'll get 90 and then this one. So what is this number? I'll take 9542, okay? Now total number here is 1, 1 minus 1 is 0, so I need to substitute 0.9542. Got it? Clear? Fine. Let us go to the next example. Yeah, we have now, suppose like this, decimal numbers are there, suppose 4.33. Okay, that is also very simple how to do, very easy. See, 4.33. For some time when there is decimal, you need to ignore the decimal. You need to forget about the decimal. So what you need to think this as 433. Okay, just find it how you find for 433. I already told you for 3 digits how you need to do. So we need to see first 2 digit, that is 43. So can we see 43 here? Yeah, 43 is here. Right, 43 is there. Then this is what? Mean difference 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So I need 43 and third one, this column. Right. What will be? 6365. Right. 6365. 0, 1, 2, 3. So I will write what first? I will write 6365. There is no fourth digit, so mean difference is not required. Only difference table will work. Okay. Now if you have this 3635, now where to put decimal? Okay. So for this type of question, what you should know? You should know that before decimal, okay, before decimal how many digits are there? 1. Right. Before decimal we have 1 digit, so I need to put 1 minus 1, that is 0. So I'll get 0.6365. Once again I am telling the rule, if there is decimal, okay, then you need to consider only the number of digits before decimal. Here before decimal there is only 1 digit, so 1 minus 1, that is equal to 0. So 0.6365 is the answer. Okay, clear? 0.6365. Once again I am telling, first of all, whenever there is decimal, first ignore the decimal and write the 3 numbers. Okay, 4433. First 2 digits we will consider from the main table, 43. Then the third digit will be taken from the difference table. So 43 and 3 we got 6365. Now here to put decimal you should not consider these 2 numbers. Before decimal how many numbers are there? 1 number is there, right? 1 minus 1 is 0. So I'll put 0.6365. Okay. Fine. Next we'll do one more question. Suppose log 43.3. Okay, how we'll solve? See, the same thing, if you see, we'll write it before decimal like this, 433, then 43 and 3, that is your 6365. Just now we did 6365, but now you see here before decimal how many numbers are there? Before decimal there are 2 numbers, right? 2 minus 1 is 1. So I'll put 1.6365. How many numbers are there before decimal? 2 numbers. So 2 minus 1 will be 1.6365. Getting? Okay. Fine. Next we'll see one more. Let us see the next example, log of 0.8. So now when the number is less than 1, okay, less than 1, then the value will always be negative. Okay, please remember this one. If the number is less than 1, okay, then log value will be negative. Log value will be negative. Okay, so now you see. So whenever it is less than 1, we will follow a different mechanism or different method. So what is this 0.8? Write it in the step 1 is write it in the scientific notation form. So I can write it as 8 into 10 to the power of minus 1. Then expand it in, so log of this one I want to find, right? Now this one log A into B is what? Log of AB is equal to log A plus log B, right? So I can write like this, log 8 plus log of 10 to the power of minus 1. Now how to find log 8? Log 8 means what? You have to imagine 80. So if you see 80 here, 80 and 0 values, this is 0, 80 and 0 value is 9031. Okay, now there is only one number in this, 1 minus 1 is 0, so I'll put 0.9031. Then log of anything to the power of 10 is minus 1, right? So just subtract this one, or how much I'll get? 10 minus 1 9, 9 minus 3 6, 9 minus 0 9, 9 minus 9 0, okay, minus 0.0969. Okay, that is what we'll get in this one. So if you are having less than 1, be very careful there. You need to write it in the scientific notation. Then you need to write log 8 plus log of, like this you expand it. Log 8 value you can easily find. You have to imagine 80 and then you need to find 9031, and because there is only one number, so 1 minus 1 0, so 0 point something will come, minus this value is minus 1, then we need to subtract it. Okay, now let us find another number, like for example I'll do another one here for you. Let us take this value, right? Log of 0.082. Suppose this is given, log of 0.082. How to find? First step is what? To write in the scientific notation. So how will I write? Okay, make it 0.0823. Okay, so first step is to write in the scientific notation. So how much I'll write? 8.23 into 10 to the power of minus 2. Right, we can write like this. Then next step is to expand it. So how will I write? Log of 8.23 plus log of 10 to the power of minus 2. Okay, now 8.23, I need to find log of 8.23. How can we find that? First I need to take 2 digits, right? 2 digits, 82 I need to consider. So that is why I have taken, because this value is there. 82 I need to consider, and then 3. So 0, 1, 2, 3. This is third, 9154. Okay, 9154. Now you need to see. So I will get log 8.23 is 9154. How, where to put decimal? See, before we need to consider only the numbers before decimal. Before decimal there is one number, so 1 minus 1 is 0. So I need to put 0.9154. Okay, so how much is log 8.23? 0.9154. Log of 10 to the power of minus 2 is minus 2, right? Now you need to solve this. So we'll get 10 minus 4 6, 9 minus 5 4, 9 minus 1 8, 9 minus 0, then I'll get minus 1.0846. Okay, minus 1.0846. Clear? So that is how you can find for numbers less than 1. Okay, fine. Let us now go for antilog. How to find antilog? Okay, so you need to find the antilog for 1.2177. Suppose. So when this one is there, okay, what you have to do, you just consider first these numbers which is after the decimal. Okay, 2177. So in the one, what is their first 2 digits you need to consider, that is 0.21. So let us see the first 2 digits, that is 0.21. Okay, next 7, you need to same thing, 0 1 2 3 4 5 6 and 7. 7 is value is 1648. Okay, so we need 1648. Then again we have 7 in the 4th digit. Here 1 2 3 4 5 6 and 7. Here you need to keep one thing in mind, that this difference table starts with 0 but mean difference table starts with 1. Okay, so 7th digit will be this 3. So I will write here, one second. So 0.21 I considered, then 7th one is 1648. So I'll write 1648. After that what I have, this 3, right? So I'll get how much? 1651. Now where to put decimal? See, the number before the decimal is what? 1. Okay, so you need to add 1 plus 1, that is 2. So after 2 places you need to add a decimal here, that is 16.51. Okay, 16.51. What I said, number, which number is there before decimal? 1. Okay, so 1 plus 1, you need to add plus 1 there. So 1 plus 1 is 2. So after 2 places you need to put decimal. So we'll get 16.51. Okay, now let us see the next question, where you need to find the antilog of 2.23249. Okay, so remember, for finding antilog or log we need maximum 4 digits. Okay, we cannot find for more than 4 digits. Here you see there are 5 digits after decimal, we need to convert it into 4 digits. So 49 we can round it off to 5. So how can I write like this? 2.2325. Okay. Now what we have to do? We have to check after decimal first 2 digit, that is 0.23. So I need to first find 0.23, that is 0.23 here. Then here are the mean difference, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right. So after this is what? Second. So I need to find the second one. So second here, and this one is 1706, right? 1706. Next what I have? 5. So 5 I have to see from the mean difference. So 1, 2, 3, 4 and 5. So that is there present here, right? So this value is 2. So how much I'll get? 1708 I got. Okay, I got 1708. Now what we need to do? Now we have to see before decimal how much number is there? 2, right? 2 plus 1 is 3. So I need to put decimal after 3 places. So answer will be 170.8. Okay, clear? Once again I'll tell you, first of all we need 4 places at max after decimal. You can have less than 4 but you cannot have more than 4. So 49 I rounded off to 5, 2.2325. Now we need to check after decimal, the first 2 digit is 23. So 0.23 I will find out. Then 2, so that I have to find from the difference, then 5 from the mean difference, right? So I'll add this and I got 1708. Now before decimal it is 2, 2 plus 1, 3. So after 3 places you need to put the decimal, we'll get 170.8. Okay, let us do one more example here, 0.7525. Okay, 0.7525. So first 2 digit you need to consider 0.75. Okay, next digit is 2. So this is 0, 1, 2. So this is what? 0.5. So we'll get 5649. Okay, 75 2 over. Now fifth, 1, 2, 3, 4, 5. Okay, and you need to check which one? The 75th row. 1, 2, 3, 4 and 5. So this will get 7. Right? Just add these two. So we'll get 5656. Right? Now before decimal there is 0, 0 plus 1 is 1. So after 1 place I need to put the decimal. So 5.656 is the answer. Once again I am telling you, first I took 75th, 0.75 this row, then 2. So difference 2, I'll get 5649. Then mean difference is 7. So in the same row I have to go 1, 2, 3, 4, 5, 6, 7. Right? So I got, 1, 2, 3, 4, 5. Yeah, this is 5, right? 1, 2, 3, 4, 5. So I got 7. I added, I got 5656. Now before decimal there is 0. So 0 plus 1 is 1. So after 1 place there is decimal. We'll get 5.656. Okay. Fine. Next one, 0.07525. Okay. So let us see how to find this one. You need to go first 2 digit. That is what? 0.07. So we'll find first 0.07. Next one is what? 5 is there, right? So next number is 5. So we'll consider 0, 1, 2, 3, 4 and 5. So here, and this one is 1189. So first we will write it as 1189. Okay. Okay. Here I told you that it cannot be more than 4 digits. So we can round it off to 5, means it will be rounded off to 3. So we'll get 0.0753. Okay. So next we'll see here 3. This is 1, this is 2, this is 3, right? So this value is again 1. So I'll add here 1. So I'll get 1190. Okay, 1190 I got. Now after getting 1190, I need to check what? Where to put the decimal. Before decimal there is 0. 0 plus 1 is 1. So after 1 place I need to put decimal. So I'll get 1.190. Okay, so that is the correct answer here. Okay. So students, this was how you can use log table and anti-log table. Now many questions were asked like whether log table is provided or not. See, log table will not be given generally for every student individually, but it will be there with your invigilator. Okay, so if you need any log table, any value you want to search, so please ask your invigilator to get log table. They will definitely give you. So in the exam, log tables will be provided. You need to ask to your invigilator. Okay, and I hope this video was helpful to find log and anti-log values. Please practice these examples and take some other numbers randomly and just do some more problems so that you are more familiar with this. Okay, so thank you for watching, and if you have found this video helpful, do not forget to subscribe the channel.